you ever tried to ask AI to transcribe and summarize your team's call meeting to make it ready to be sent to team members that didn't attend? Have you thought about what actually happened behind the scene? How did your voice get converted into text and then turned into something useful inside an application? If you are wondering how developers build experiences like this using Azure, you are in the right place. Hi, I'm Sarah Alali, a senior technical trainer at Microsoft, specializing in AI, copilot, and building intelligent and secure applications on Microsoft Azure. I have a PhD in computer science and 12 years teaching training experience. This course covers 12 sessions, where we will dive into core AI concepts in Azure and learn how to turn ideas into real applications using modern tools like Microsoft Foundry. In session number 8, we will show you how to use speech capabilities in Azure. We will explore different ways to get started, from simple experimentation in the playground to integrating speech into applications, all the way to using it inside AI agents. Let's see how speech recognition fits into real-world scenarios. Imagine a company that wants to capture insight from spoken conversations. Customer support calls maybe, Teams meeting, interviews, or even voice notes recorded on a phone. All of this information is valuable, but only if it can be turned into text. That's where speech recognition or speech-to-text comes in. We have seen in a previous video how this works. In Azure, speech-to-text is available through Azure Speech in Microsoft Foundry. And there are 3 simple ways learners can try it. The easiest way to get started is directly in the Foundry portal playground. Here, you don't write any code. You upload an audio file or you speak into a microphone, and Azure converts your speech into text in real time. This is perfect for learning and also for experimenting. For example, you can upload a meeting recording and instantly see a transcript. It helps you understand what speech-to-text does before building anything. The next step is using the Azure Speech SDK in an application. This is how developers integrate speech recognition into real systems. With the SDK, an application can listen to audio from microphone, process audio files, and automatically generate text transcription. For example, a customer support application can transcribe live calls, so agents don't need to take notes. A productivity app can turn voice notes into searchable text. You don't need to memorize the code. What matters is understanding the flow. Audio goes in and text comes out. The third option is using Azure Speech in Foundry tools with agent through the Model Context Protocol or MCP. In this case, speech recognition becomes a tool that an AI agent can use. For example, an agent can listen to what a user says, convert it to text, analyze the text, and then decide how to respond. This is how voice-enabled copilots and assistants are built. All 3 approaches use the same underlying speech-to-text capabilities, but they support different learning and business needs. The playground is great for exploration. The SDK is ideal for building applications. Agents enable conversational end-to-end workflows. To get started with speech recognition in Azure, you don't need to know everything at once. You just need to understand where speech-to-text fits, how audio becomes text, and which entry points make sense for your scenario. At this slide, we have an example of an SDK call. Now let's take a high-level look at what the code is doing. You don't need to memorize this code. What matters is understanding the flow. At the top, the application imports the Azure Speech SDK. This SDK gives the app everything it needs to work with speech services in Azure. Think of it as a toolbox that lets you or lets your application listen to audio and turn it into text. Next, the code creates a speech configuration. This is where the application tells Azure who it is and where to connect. It provides the Foundry endpoint and an API key. This step is all about authentication and connection. Nothing is being transcribed yet. After that, the application defines an audio configuration. In this example, the audio comes from a file called voicemessage.wav. This could just as easy like a microphone or live audio stream. But for this example, we are using a simple audio file to keep things clear. Now the application creates a speech recognizer. This object brings together the speech configuration, the audio configuration. At this point, the system knows where to connect and what audio it should listen to. Next comes the actual speech recognition step. The code calls a method that says, in simple terms, listen once, recognize what's being said, and give me the result. Azure processes the audio, applies the speech recognition models, and converts spoken words into text. Finally, the application prints the recognized text. And this is the end, the results, which means the audio gets in and finally the text comes out. We looked at speech recognition, where spoken audio is converted into text. Now we are moving to the parallel capability, speech synthesis, also called text-to-speech. If speech recognition helps application listen, speech synthesis helps application to speak. Imagine a healthcare app that reminds patients of upcoming appointment. Instead of sending only text notification, the app can call the patient and say, Dr. Chen's appointment is scheduled for today at 3 p.m. This is an example of speech synthesis, turning text into clear, natural audio. In Azure, this capability is provided by Azure Speech in Microsoft Foundry tools. Conceptually, speech synthesis follows the same idea as speech recognition, but in reverse. Instead of starting with an audio and ending with a text, it starts with a text and ends with the audio. In previous session, we explained how this works under the hood. So just like speech recognition, there are 3 ways to use speech synthesis in Azure. You can explore text-to-speech directly in the Foundry portal playground without writing any code. You can also use Azure Speech SDK to generate spoken audio in an application, choosing voice as a part of the configuration. Or you can enable speech synthesis inside an AI agent using Azure Speech in Foundry tools through the MCP server, allowing the agent to speak as part of a conversation. Let's walk through one simple story to understand how speech synthesis is used in Azure. Imagine a product manager named Alex, who is building a voice feature for a travel booking application. Alex starts in the Foundry portal playground. There is no code involved yet. Alex simply pastes a sentence like, your flight to Paris departs today at 4:30 p.m. from Terminal B. With one click, the system reads the message aloud using a natural-sounding voice. This instantly shows Alex how text-to-speech works. Alex can experiment with different messages, hear how numbers and times are spoken, and try multiple voices to find the right tone. At this stage, the goal is simple: explore and listen. Once Alex is happy with the playback, the next step is the Azure Speech SDK. Now Alex wants the application itself to generate audio automatically. So using the SDK, the app sends text to Azure Speech and receives the spoken audio in return. As part of a configuration, Alex selects a voice that fits the product: clear, friendly, and professional. For example, every booking confirmation or boarding reminder can now be read aloud, either through a speaker or as an audio file. Alex doesn't need to memorize the code. What matters is understanding the flow. Text goes in, audio comes out. Finally, Alex takes one step further by adding an AI agent using Foundry through the Model Context Protocol, or MCP. Alex connects Azure Speech Synthesis as a tool the agent can use. Now, the agent can decide when to speak. For example, the agent confirms booking details, answers a follow-up question, and then reads the response aloud as part of a conversation. Speech synthesis becomes part of an agentic workflow, not just a separate feature. It is the same text-to-speech capability used in 3 stages. Alex explores in the playground, implements it with the SDK, and scales it inside an agent using MCP. That's how speech synthesis in Azure moves from experimentation to application development to fully conversational AI experiences. In the slide, we have an example of the SDK code. Now let's look at this code and relate it to the previous example we just saw. The first thing to notice is that we are using the same Azure Speech SDK. Just like with speech recognition, we start by importing the Speech SDK, which provides all speech-related capabilities. Speech recognition and speech synthesis are part of the same platform and use the same tools. Next, we create a speech configuration, exactly like in the previous example. We pass it in the same API key and the same Foundry endpoint. This means the application connects to Azure Speech in exactly the same way as before. The difference is not the connection, it is what we ask the service to do. Now we add one new configuration details, the voice. Here, the code specifies a particular voice name. Choosing a voice is part of configuring speech synthesis, just like choosing a language or accent. This tells Azure how the output should sound. For example, calm, clear, or maybe more expressive. And like speech recognition, we don't need an audio input this time. In the previous example, we pointed to an audio file to listen to. Here, there is no audio configuration because we are not listening, we are speaking. Next, the code creates a speech synthesizer. This object plays the same role as speech recognizer. It takes the configuration and prepares the service to generate speech. Then comes the main action. The application sends a piece of text to Azure Speech. Azure processes the text, apply normalization, pronunciation, prosody, and generate spoken audio. Finally, the result is returned. Instead of getting text back as we did with speech recognition, we now get an audio output. Speech that can be played through speakers or saved as a file. Up to now, we have seen how speech recognition and speech synthesis work really well on their own. Speech recognition turns audio into text. Speech synthesis turns text into audio. That covers many scenarios like transcribing meeting or reading notification aloud. But really, conversations are more complex than that. People interrupt each other. They change their mind in the middle of the sentence. There is background noise and conversation flow back and forth in real time. That's where Azure Speech Voice Live in Foundry tools comes in. Imagine Alex is building now a voice-enabled travel assistant. A user speaks to the app in a busy airport. The app needs to listen, respond quickly, handle interruptions, and keep the conversation going naturally. Using simple speech-to-text and text-to-speech together would feel clunky. There would be pauses, delays, and broken interactions. Alex needs something designed for live conversation. Now, what is Voice Live? Voice Live enables real-time conversational speech with a generative AI model that has instructions and tools. Instead of stitching things together manually, Voice Live handles continuous listening, natural speaking, background noise reduction, and interruption. The conversation feels fluid, much closer to how people actually talk. Alex starts by experimenting in the Foundry portal playground. In the playground, Alex can speak naturally and hear the agent respond immediately. No code, just talk and listen. This helps Alex understand how a real-time voice agent behaves before building anything. Next, Alex moves to the Azure Speech Voice Live SDK. Now, the goal is to build a client application that supports live conversation. The SDK handles real-time speech recognition, real-time speech synthesis, and smooth turn taken between user and agent. This is very different from sending a single audio file or generating a single spoken reply. It's continuous, interactive, and designed for conversation. Finally, Alex connects everything to an AI agent using the Model Context Protocol, or MCP. With MCP, Azure Speech becomes a tool the agent can use. The agent can listen to what the user says, understand intent using a generative model, and call other tools if needed, and respond immediately with natural speech. Tool access is governed and explicitly approved, so the agent only acts within safe boundaries. Speech recognition and synthesis are powerful, but they are not designed for live conversational interactions on their own. Voice Live fills the gap. It brings together real-time speech, generative reasoning, tool integration, and noise handling. This is how modern voice copilots and conversational agents are built. And don't worry if it feels abstract right now, because we are moving directly to a demo. Now let's do a quick exercise where we will get started with speech in Microsoft Foundry. And in this exercise, we will explore the Azure Speech in Foundry tools and the Voice Live services. You can also practice this exercise in your environment by accessing the lab steps in the link that you can see on the screen, or by visiting the AI-901 learning path through the Microsoft Learn platform. Let's go. In this exercise, we're going to work with speech in Microsoft Foundry. And we're going to look into speech-capable AI agents that enable users to interact conversationally using spoken command and questions that generate vocal response. So in this exercise, going to use the Azure Speech and Microsoft Foundry tools to create speech-enabled agent. So as usual, we start from the Microsoft Foundry portal, where we are going to keep working in the same project that we start with from the beginning of these sessions, which is our Foundry demo project. In the same subscription, same environment, so you can create your own also and work on it. So I'm going to start by creating an agent. I'm going to give a name to our agent, which is going to be speech agent. And next, we're going to select the right model that we are going to use with this agent. So here I'm going to keep it with model GPT 4.1, model that I already created in my environment previously, but I see there is other models that we created during all these sessions. And next thing, I'm going to specify the instructions. I'm going to tell it that you are an AI agent that provides information about AI and related topics. You answer questions consistently and precisely. So I'm going to save all this. And we're going to start out with the first prompt, easy prompt, asking, what can you do? What can you help with? Amazing. So I see help with AI concept technologies, providing up-to-date information, answering questions about AI, helping, etc. Okay, so let's configure a little bit things here for our agent to make it useful to our example. So first thing, we're going to turn on the voice mode. So when you turn on the voice mode, you can see here there is some specific configuration that you need to put in place to be able to work with the agent the way you prefer when it comes to voice. So you can see here I put in auto detect. We have also some advanced settings, so you can put any Azure semantic VAD. You can configure audio enablement. So you can decide either configure other advanced thing like end of utterance. So here's detects. It really detects the end of the speaking and stops speech recognition processing, returning result. You have also the audio enhancement that improves sound quality by reducing noise and boosting clarity, ensuring more accurate and clear speech recognition that you have. You have the phrase lists also that improve transcription accuracy by providing a list of known phrases, such as, for example, names of people, specific location, and so on. You can also select some voices. I'm going to let you hear some voices, and then we select just one of them.
From the research lab to the big industry players, we've got you covered.
From the research lab to the big industry players, we've got you covered.
From the research lab to the big industry players, we've got you covered.
Now that we listened all of them, we select the one that we prefer. Personally, I preferred Emma, so I'm going to select Emma. We have the advanced settings. So we see here we have, for example, the voice temperature. And this values is a float ranging from 0 to 1, influencing the randomness of the output. So again, the lower temperature result is less randomness, leading to more predictable output. And the higher temperature, it's increased randomness and allowing for more diverse output, right? We have also the playback speed. You can configure it. You can configure the custom lexicon. This defines the pronunciation of specific words, for example, company names, medical terms, or emojis. So you can configure that also. You have the interim response. You can provide like a brief interim audio messages to reassure users that a response is being prepared, like something like this. And proactive engagement also initiates conversation and actively responds during a silence to keep the interaction engaging and continuous and feels more like human-like. We have also the avatar. So you can set the avatar. So you can select from a long list of avatars. There is some like stand-up avatars. There is like some faces that can speak. So you select whatever you find more comfortable with. So here's the long list. So you can choose. There is a photo avatar. There is also video avatar. So you decide which one makes more sense with you. So I'm going to select Meg. It feels that looks a little bit like me for some reason. And let's have the conversation with Meg using the Emma voice. So let's start with Meg with Emma voice and save everything here and start having a voice conversation with it. Okay, we're going to start a session here. How does speech recognition work?
Speech recognition, also known as automatic speech recognition, ASR, works by converting spoken language into text through several key steps. Number 1, audio input. The system receives a voice signal from a microphone. 2, pre-processing. The audio is cleaned to remove noise and then transformed into features using techniques such as mel frequencies, substral coefficients, MFCCs, to represent the sound in a useful way for computers. 3, acoustic modeling. Machine learning models, often deep neural networks, map the audio features to phonetic units, the basic sounds of language. 4. Language modeling. Another model predicts the probability of word sequences, helping the system select the most likely transcription based on context. 5. Decoding. The system combines acoustic and language models to decode the spoken input into text, selecting the most probable sequence of words. 6. Post-processing. The final output is cleaned up, correcting grammar and punctuation if needed. Modern systems typically use deep learning, particularly end-to-end models like recurrent neural networks, RNNs, and transformers, which can learn directly from vast amounts of speech data and improve accuracy over traditional methods.
Okay, I'm going to stop it here because there is a long text coming from here and reading it. So you can also try out something else. Okay, I'm going to start a new chat here. Let's put a configuration here to see something different. I'm going to remove actually the avatar. I'm going to keep it just a discussion without an avatar here. I'm going to save it here. And I'm going to ask something else. How does speech synthesis work?
Speech synthesis, also known as text-to-speech, TTS, is the process of generating spoken language from text. Here's how it works. 1. Text analysis. The system analyzes the text input to determine the structure, punctuation, and pronunciation, including handling abbreviations, numbers, and homographs. 2. Linguistic processing. Converts text into phonemes, basic sound units. Applies rules of grammar.
Okay, I think it's enough. We get the idea. You can also see here, they can have also information in text. Let's look into the YAML file actually here for our speech agent. So I can see here the name is speech agent. I can see here the model that we have. I can see also the instructions. So you are an AI agent that provides information about AI. So whatever we configured actually, the type of the tools we have the web. And in the code side, we can see all the code that we needed from the all libraries that we need. So we have different libraries that allow us really to have live discussions. So you can see here the Azure AI Voice Live that we are using here. All the things that we need to catch the text from the audio, from the microphone, and also to speak through the speaker. All these things are pre-configured. So here we have a little bit much longer code than the codes that we previously seen, because there is a lot of things happening in the audio and in the speaker part. Also, if you feel comfortable in other programming language, so you can select, for example, C#, and you can see the piece of code in C# too. Okay, that's it for this demo. I hope you enjoy it, and let's get back to class. In this session, we discussed how Azure speech capabilities, speech-to-text, text-to-speech, and real-time voice live can be used through the Playground, SDK, and AI agent to build and scale from simple experiment to fully conversational voice-enabled application. Remember that all this material is available for free on the Learning Path, and you can find the full Learning Path at the Microsoft Learn platform. This concludes our session. Thanks for joining us for this session. To continue your learning, we encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. Happy learning!